The overlap between orbitals forms a new hybrid orbital. And this contains two electrons of opposite spin force. Chemists call this hybridization. The S and P went to form hybrid orbitals.
There are many arrangements. sp2 and sp3 examples. sp2 has an empty p orbital and 3 hybridized orbitals. sp3 has no empty orbitals and a bonding capacity of 4. A bonding capacity of 4. A bonding capacity of 4.
Bonds and valence electrons between the nuclei and molecules to form hybrid orbitals. The valence bond theory, the covalent bonds share valence electrons between the nuclei and molecules to form hybrid orbitals. It's a party in the chemistry class. The valence bond theory, it's a party in the chemistry class.
Hybrid orbitals act between the bonds of CH4. Carbon has 4 electrons in the center of shell. 2 on the S and 2 on the H3 orbital. This is a problem because they are negative and the electron in the S. A pair which prevents overlapping.
To solve this, chemists propose electron formation from an s to the sp orbital. The sp orbital is hybridized to form sp3 hybrids. To form sp3 hybrids. To form sp3 hybrids. Pi bonds and sigma bonds are types of covalent bonds. Sigma bonds are created by end-to-end overlapping. A single bond is an example of a sigma bond. Pi bonds are formed by parallel non-overlaps.
Double bond is 2 and pi bond. A triple bond is 2 pi and 1 sigma bond. sp2 and sp are accompanied with these bonds. Ethane, acetone, 2 hybrids. Ethane, 1 normal and 3 hybrids. And hybridized from pi bonds. The hybridized from sigma bonds. The hybridized from sigma bonds.
Bonds and valence electrons between the nuclei and molecules to form hybrid orbitals. The valence bond theory, the covalent bonds share valence electrons between the nuclei and molecules to form hybrid orbitals. It's a party in the chemistry class. The valence bond theory, it's a party in the chemistry class.
Explaining the geometric arrangement of molecules. First, construct the lowest dot diagrams. Thus, perhaps with the arrangement of electron pairs from its geometric arrangement, deduce the hybridization type.
Form bonds to the central atom by overlapping singly occupied orbitals of the other atoms with singly occupied hybrid orbitals of the central atom.
Now let's talk about the different geometrical arrangements. An atom with 2 identical atoms on each side have linear geometry. sp is the hybridization type. 2 pair orbitals overlap to form 2 sigma bonds. Carbon dioxide is a classic example. Adding 3 surrounding atoms make the trigonal planar. The type is called sp2. A central atom of 4 surrounding atoms is called tetrahedral and has sp3 orbitals. And that's all for now.
I don't like bonding with this guy, but I don't really have a choice. Cause our schedules overlap. I guess I just have to form sigma bonds.
Bonds and valence electrons between the nuclei and molecules to form hybrid orbitals. The valence bond theory, the covalent bonds share valence electrons between the nuclei and molecules to form hybrid orbitals. It's a party in the chemistry class. The valence bond theory, it's a party in the chemistry class.